Hello, I am Safiul Baksh. Today I am going to discuss electromagnetics. It is a very important topic in GATE syllabus. But before that, I want to discuss about the motivation behind the GATE examination. Secondly, why is EMT important in real life or industrial life or in the life of science and in GATE examination. And after that I will discuss the syllabus of the electromagnetics and I will enter in the basics of the electromagnetics. So GATE is an important examination. Of course there is no doubt about that GATE is an important examination. There are various opportunities after GATE. Once you have done your degree in engineering, if you want to be in the field, if you want to contribute to the society and to yourself and to your family in a very reputed manner, GATE is the next gateway. Through GATE, the opportunities are already that IITs and NITs, the MTech, then public sector undertakings, and very much private sector core jobs, they now recruit through the GATEs, and reputed training centers, they also invite bright students who cleared the GATE. So in that perspective, GATE is an important examination. Secondly, if you prepare for GATE, then you will be prepared for other exams like engineering services. Almost 60% job of the engineering services will be done in the preparation of the GATE. And also other exams like Indian Space Research Organization, Bhabha Atomic Research Centers and other central government institutes or companies. So that's why GATE is a very important examination. Next come to that subject, electromagnetics. This is a heavy weightage subject in GATE. If you see the recent trends like 2014-2015, there are a lot of questions asked from electromagnetics, and all those are from the basics. You don't need to be do like critical mathematics, just you need to clear your basics. And past trend shows that around 5 to 6 questions comes from electromagnetics in GATE. So that's why it is too much important in GATE perspective. Also, if you see the changes in the syllabus of engineering services exam, there also few subjects has been trimmed out and few subjects has been added. But electromagnetics is one of the subject which is constant still for electronic students. That's why it is so important. In real life, if you do research in kind of communication sector or space sector, so their electromagnetics concept is very important. Also, if you want to serve kind of Air Force sector, electromagnetics concept is very important for electronic students. Now let's discuss about the syllabus in electromagnetics. The whole syllabus provided in GATE is divided into these 6 chapters this year. First is Static Electromagnetic Field, second is Electromagnetic Waves, third is VI waves, that is transmission line, then guided waves, that is waveguide, then radiated wave, that is antennas, and lastly this is a new addition, light propagation in optical fiber. Now when you will learn this electromagnetics, the 50% of my focus will be in this static electromagnetic field, and rest 50% of my time will be taken by this 5 subjects. So this is very important. Static electromagnetic field is the base for this subject. As soon as you complete this static electromagnetic field part, you are 70% prepared for this subject, and the the rest portion of these subjects are based on this foundation. So what is static electromagnetic fields? It discusses about DC phenomena. It is about like static with the time. And this force, these are discuss about something AC phenomena, which are not static with the time, which are changing with the time. If something is changing, that means the electric fields, magnetic field that is changing with the time, then these phenomena happen. So this is AC part. Now let's discuss the first portion, which is the foundation for this electromagnetics. If you clear this, if you make strong this first portion, then you will be more you'll be confident enough to enter in the rest parts, and you'll be these rest parts will be easy for you. So let's discuss the first part. Static electromagnetic field. Now, energy is two type, you can say, two kind. One is particle energy, one is wave energy. In particle energy, it can be divided into two categories, like mass, energy in mass, and energy in charges. Energy in mass, what it can be? It can be potential energy and it can be kinetic energy. Energy in charges, it can be divided into two types. One is E field and another is H field. Now, what is E field and what is H field? Will come together. This is the entry of the subject. When charges are stationary, it is E field. When charges are moving, it is H field. Now, what is E field? E field is a format of energy which is all around a charge and which influences other static charges. So there are two terms, which is that format of energy around a charge particle and influences other similar charges. And what is magnetic field? Similar, it is a format of energy which is all around a moving charge and which influences other similar moving charges. So there is a term difference. For magnetic field I am using moving charge and influences other similar moving charges. So it is same, instead of it is same moving charge and influences other moving charges. So that is it. Now, what I want to mean by influence in electric field, and in magnetic field. That is important. So let's see. The word influence in electric field, it represents the attractive force or repulsive force on other charges. So due to this, the other charge is accelerated or accelerated in a linear path following the Coulomb's law, which goes like this: Q into E equals to the force on the other charges, that is equals to MA. So this is Coulomb's law. Now, so the result is the acceleration of the particle in a linear straight path. What is the word influence in magnetic field? Now in magnetic field, the word influence actually, it is on the charge which is already moving. Okay, it is on moving charge. Now the force is on the moving charge, and the direction of the force is perpendicular to the direction of the moving charge. So it is like perpendicular, force is perpendicular to the direction or velocity of moving charge. So what you can see, that the force is perpendicular to the velocity of the moving charge. That means the work done by the force is 0. So this is according to the Lorentz law. So what it says, it is Q V cross B equals to the force, which is M V square by R. So here the effect is that when there is a magnetic field, suppose there is a magnetic field in this direction, some charge is moving in this direction, now there will be force felt on this charge, and that force will be perpendicular to its direction. That means that can be like in this direction or in this direction. So this plane was like going in this direction, now it is facing a force in this direction. So there will be neat force. So let's see what is that. Let's take a magnetic field. Into the board. Let's take a magnetic field into the board. It is indicated by BZ. Okay. Now, if a charge, so magnetic field is into the board. Okay, those lines are into the board. Now, if a charge is thrown, like a charge Q1 is thrown with a velocity Vx in this field. Okay, magnetic field, the charge is thrown. Now, what is the force on this charge that we get from this Lorentz law? That means that is the influence in the magnetic field. So let's analyze it. But before going into this, let's discuss, in my whole discussion of the electromagnetics, what would be the coordinate system? This. This all we have studied in class 11 and 12. Okay. So if we proceed further with this concept or with this structure, the electromagnetics will be a cumbersome job. Okay, it would be a tough job. Now, that's why we have to consider the Cartesian coordinate as like this. Here comes your imagination part. That means, you know, if it is x, if it is y, then the z is out of the board. We will not draw it like that. We will just think the concept, it is out of the board. When I write a dot, it is out of the board. Tip of the arrow, okay, it is out of the board. When I write a cross, it is into the board, back of the arrow, okay. The arrow looks like this, okay, you know, it is tip of the arrow, so it is coming and it is crossed like it is going. So now, what would be the force? We know. What is the force? V cross B. That means the force, let's write it here. The force F equals to Vx cross, what is the Bz direction? If it is Z, positive Z, if it is into the board, then it is negative Z. So it is B of minus Z, you can say. So, you know, X cross Y equals to Z, Y cross Z equals to X, Z cross X equals to Y. Now, if I say X cross Z, that is minus Y, okay? And if I say X cross minus Z, that is minus and minus Y, that means X cross Z, so that is Y, okay? So force is in Y direction. We need to write it like this. Force is in Y direction. That means the force felt by this charge in this field, suppose it is already entered into the field, okay, so in this field would be in perpendicular direction. So this charge, if we throw this charge in the magnetic field, this will feel a force perpendicular to its direction. This is its direction, it is feeling a force perpendicular. So the net force, the net movement of the charge will be in this direction. Got it? It would be in this direction. Now the next time, next very instant, this force will again feel. So first it was moving in this direction, next it is, again it will feel the force in perpendicular direction. So it would be like this and it is going. So the resultant is this. So you can see the particle is started taking a curved path, okay. So the net result is that the particle will take a circular path, that will be like this. If you throw a particle, charged particle in magnetic field, that will take a circular path, okay. So it is kind of that. These are tangents. So that is the analysis for Lorentz law. So what is the summary? Let's take the summary of this basic concepts. So if Q is static, leads to electric field, E field, okay, Q is static, it leads to electric field, okay. This electric field is not varying with time. Q is static, fixed amount of charge is static, it has electric field around it. This is not varying with time. So this is time invariant. But see, if I have charge here, it has field around it everywhere. See, here if you see the density per unit area, it is larger. If you see the density here, it is lesser. So it is space varying. If Q is moving, okay, in without any acceleration, linear with time, then this leads to magnetic field, okay. This is also time invariant. So these are the two important summaries.